So there are really two main types of kidney or renal failure, um, or two classifications. You have the acute renal failure, acute kidney injury, acute whatever, um, and then you have chronic kidney disease. And we'll talk more about the difference between these two things, but basically anytime you see the word acute, we are talking about something that is sudden or abrupt. It's just happened. It's not something that has been there for a long period of time and it's been building. Okay, something that's been there for a long period of time and is often progressing is chronic. Something that has just happened. Again, it usually happens over a period of sometimes hours, days, maybe weeks, but chronic is happening over a very long period of time, okay? And so let's talk about what, I just need to flip my slide here. So like with most things, you have mild kidney injury and more severe kidney injury. This slide is saying a lot of what I just said. We talked about the purpose of the kidney, filtering blood. One of the two of the biggest things that it filters that we can measure in the blood are creatinine and blood urea nitrogen. Okay, so when the kidney is not working, something has happened, and we'll talk about causes in another video, but something has happened. The kidneys, the nephrons, they're not working properly. It's not filtering what it's supposed to be filtering. So creatinine, which is basically just a byproduct of muscle metabolism. So as your muscles are working, it's releasing creatinine, okay? But we don't need this creatinine, so it's usually excreted. It is absorbed into the nephrons, and then through the tubule, and then it's excreted through that tubule. It's absorbed, and then excreted into the urine. Okay. Blood urea nitrogen starts kind of in the liver. Okay, so when the liver breaks down proteins, there's a byproduct called ammonia, which I'm sure you guys have heard of. This is a fairly toxic compound, and so the liver will metabolize. And again, this is just kind of the basics, right? Just the way that it's easiest to think of it for our purposes. Basically, the liver metabolizes the super toxic part of it, and basically changes it into urea, which is a lot less toxic, and that can be transported in the blood to the kidneys. Okay, that urea, when the kidneys are not working properly, that urea is not excreted in the urine, and it is reabsorbed or builds up in the blood. So when your kidneys are not working, and basically, guys, whether it's an acute kidney injury or chronic renal problem, when it gets to the point where those nephrons are not working properly, you're going to have this high serum or blood creatinine and BUN, because it's not filtering, okay? So it's really important to just kind of remember that, regardless of whether we're talking about acute renal failure or chronic renal failure, when the kidneys aren't working, they're going to basically do the same thing regardless of the cause, kind of. So one of the other things that the kidney does, we talked about fluid retention. We talked about the sodium potassium kind of relationship between sodium and potassium. So one of the big things the kidney does is it excretes all the potassium in the body. We'll talk more about this. I have a whole just a section that just talks about potassium, calcium, phosphate, and magnesium, just kind of going over those, because I know that was kind of a struggle. And it was it's for me too. So it's good to kind of just break it down and go through it. But anyway, the kidneys are, one of the biggest things they do is they filter out the potassium in the body. So again, when the kidneys are not working, the potassium is going to build up in the bloodstream. Okay, so some really, really big signs of kidney failure, whether it's acute or chronic, you're going to have creatinine, BUN, and potassium in larger amounts in the blood. Okay, now one of the differences between acute kidney injury and chronic injury is that acute kidney injury or acute renal failure is potentially reversible. So we're going to talk in another video about all the causes of AKI. If you fix that problem, whatever it is that's causing the damage to the kidney, and there hasn't been any permanent damage done to the kidney, once you fix that problem, the nephrons and the kidney just starts working again. And remember, we talked about in chronic renal failure, you don't really get symptoms until 50% of the nephrons aren't working. You've lost 50% reduction. There's been a 50% reduction in the function of the kidney, right? So if you think about it kind of like that, and I don't know that this is necessarily like, the scientific way of thinking about it, but I think about it like an acute kidney injury hasn't reached that point where it's permanent damage yet, right? And so you have all the symptoms because they're not working, but then once you fix that, those symptoms will go away because you haven't reached the point of no return yet, like you do in chronic kidney disease chronic kidney disease. Okay, I'm going to flip slide here. We did talk about this in another video, but let's go over it again. So we talked about the glomerulus, which is a part of the nephron. And it's the main point of the glomerulus is to filter. It's kind of the first step of filtering the blood. And so it uses hydrostatic pressure to pull the blood out of the substrate or the filtrate out of the blood. It leaves the blood in the capillaries, the red blood cells, platelets, large proteins. It stays in the capillaries, but the filtrate comes out at that point and filters down into the rest of the tubule, the loop of Henle, and all that stuff we talked about before. So it usually filters the blood at a rate of 125 milliliters per minute. Okay. And that GFR, or glomerular filtration rate, is really, really important in terms of measuring kidney function, right? Because if your GFR is extremely low, your kidneys are not filtering the blood. And so really, I know a lot of people kind of struggle with the GFR, but it is really, really a very basic concept for our purposes, for nursing, just understanding. It's the rate at which that part of the nephron, the glomerulus, is filtering the blood. And again, it's the first contact, it's the first place it's being filtered. Okay, and if you guys have more questions about that, feel free to email me or ask, but honestly, I can't see us needing to know more than that. Yeah. So I do think it's interesting. I don't know that you need to know this, but it's interesting that the kidney actually gets 20 to 25% of your cardiac output. So 20 to 25% of the blood that is being pumped out of the heart to the body is going to the kidney, whether it's used to perfuse the kidney or used to be filtered. 25%, which is actually huge, right? And so those kidneys are working really, really hard all the time. The last slide I wanted to show you in this video is just this quick rifle classification. And basically this is just giving you like the levels of injury, I guess. So you know, you have risk, you have injury, you have kidney failure, now you have kidney loss, and this is end-stage renal disease, right? So really the takeaway from here is this relationship between your GFR and your urine output, and how, you know, as your GFR is decreasing and your creatinine is going up and your BUN is going up, your urine output is decreasing as well. And that's because of that. One of the main functions of that tubule is to concentrate the urine, right? It pulls the fluid out of the body or out of the capillaries in order to concentrate the urine or dilute the urine, and then it excretes in the body. If the nephron's not working, that fluid, instead of being excreted in the urine, is actually being retained. You have fluid retention in your body, which means it's gonna slow down your urine, right? You're not gonna pee as often. And it goes to the point of, you know, it starts off with oliguria, which is just not peeing very often. It's not, I think it's 400 milliliters, or between 100 and 400 milliliters in a 24-hour period. Here they base it on your weight, which is great. I just like to think of it the other way because it's just easier. And then Urea, which is no urine or very, 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 very little urine. Understanding the relationship between those things, right? So the kidney is not working, your glomerular filtration rate is going to go down because the blood that's coming in is not being filtered quickly or properly. What is being filtered is then not being properly diluted, because instead of the kidney using the fluid to dilute that filtrate, it is being retained in the body. So now you've got all of that waste building up in the bloodstream, and your urine will be very, very concentrated and will not have the fluid to dilute it, okay? And I think we'll stop there for this video and we'll move on to the causes.